Okay, students, so we're here with medians and centroids of a triangle, phase 2. We talked about this stuff yesterday, but we're going to talk about it again today, just strengthen our skills and have a better understanding. All right, so what is so special about a centroid? What exactly is a centroid? Well, it's the balancing point of a triangle. All right, and you can also call this the center of mass. Balancing point, center of mass, so it's literally where the triangle balances. Now, how do you determine the location of a centroid? It's the point of concurrency of all three medians. All right, point concurrency, I probably spelled this word wrong, but that was nothing new, me spell something wrong. Point of concurrency is intersection of the three lines. All right, there's different points of concurrency. This specific one is the intersection of the three medians. Now, what is a median? A segment that connects the midpoint of a side to the opposite angle. All right. And think about this like a median of a road. A median is like that green space in between two sides of a road. It's the middle of a road. A median is like the middle of a triangle. All right. So we practiced a whole bunch of things about medians yesterday, if you can recall. So we would find, if you can recall yesterday, we would find the three midpoints of each side. Then we would have to connect the midpoints to the vertex to determine the location of the centroid. So really fast, this isn't going to be completely accurate, so don't even write this down. But like you'd say, okay, these are the three midpoints. Then you connect, that's a median, that's a median, and that's a median. And where they all intersect, you'd say, okay, that's my balancing point. Can take a long time, though, to calculate the midpoints, then to connect them and all that stuff. We have actually an algebraic shortcut. And I really love this algebraic shortcut because it reminds me of another formula that we have. And I think it's just quicker. All right. So this is the centroid formula. This is how you calculate the centroid. And remember, we use point P for the centroid. Why? I have no clue. All right, to me, it sounds like we should use the letter C, but they didn't ask me. So you add up all the x coordinates together, divide by 3. You add up all the y coordinates together, divide by 3. All right, now before we solve this, let's look at this right here. What formula does the centroid formula remind you of? Midpoint formula. All right, it's incredibly similar to the midpoint formula. All right, and the midpoint is the balancing, I'm just going to write balance point of a segment. So if you cut a segment in half, that's where it balances. And if you can remember the midpoint formula, is you just add the two x's together, divide by 2. You add the y's together, you divide by 2. All right. So the balancing point of a segment is the midpoint. The balancing point of a triangle is a centroid, and that's why their formulas are so similar. You're basically just finding the average of the coordinates. That's why in the midpoint you divide by 2. That's why in the centroid you divide by 3. So let's dive in and let's just really quick write out each of the coordinates. E is 10, 7. F is 4, negative 2. And then D is negative 8, 4. All right, so you literally just take all the x's, negative 8, 4, 10. We're going to add them together right here eventually. And then you do y. Again, the order doesn't even really matter. But we'll keep a little consistency. So negative 8 plus 4 plus 10 divided by 3. And then over here we have 4 minus 2 plus 7 divided by 3. All right, and then just a series of calculations. What's negative 8 plus 4 plus 10? That's going to be positive 6 over 3. 4 minus 2 plus 7 is going to be 9 over 3, which goes to 2, 3. All right, so without finding a midpoint, without finding a single median, we are still able to find the centroid with this formula. So 2, 3 right there, that's the balancing point. If I cut this triangle out of my iPad, not only would I destroy my iPad, but I would also know where exactly to balance this triangle, and that's that. All right, so we practice it. Let's just do it one more time, okay? So let's write the centroid. Before I even look at the triangle, I'm just going to rewrite the centroid formula. Repetition is good. And remember, this is an ordered pair. So that's why I have that comma right there. Don't forget that comma. That comma is important. Now A is 1, 1. B is 5, 2. And C is 3, 5. All right. So it's literally just add my x's together. 1, 5, 3, divide by 3. And then 1, 2, 5, divide by 3. All right, and this problem is going to emphasize some things on why I like the centroid formula. But again, we're going to get 9 over 3, and then we are going to get 8 over 3. Which goes to 3 and 2 and 2/3. All right, or we could write it as 3, and we can have some little bit of rounding, about 2.7. All right, that's why I like this. We got a decimal. Sometimes if you get messy numbers, like would we know that point if we found the centroid was exactly what it is? No, we would have to kind of guesstimate. So we're going to write 2.7, round, but that's it, all right? So we got the stuff from yesterday, finding the midpoints and all that stuff really fast. If I calculated the midpoints, there'd be a midpoint there, a midpoint there, and you connect them and see how this would work, all right? A lot of fun stuff. These centers of triangles I do find interesting, the end center, circumcenter, centroids, really good stuff. And in fact, that's what we're going to be practicing in the rest of the notes.